Okay, let's explore the basics of exponents. I'll start with an expression here, and we'll look at what it means. First, let's label the parts of this expression. The 4 is what we call the base, and the 3 is the exponent or power. Okay? And there's a couple different ways you could read this. You could read it as 4 to the third power, or anytime you have a third power, you could say it's a cube. So you could say this is 4 cubed, and that means to the third power. Okay? The meaning of this expression is it's a shortcut for writing multiplication. It means 4 times 4 times 4, where there are 3 4's being multiplied. And of course that is 64. Okay? A couple other examples. If I write negative 4 cubed like this, then the 4 again is my base, and the 3 is again my exponent. And this negative out here just means to take the opposite of the entire expression. So this means the opposite of 4 cubed. The negative is not part of our base. So in other words, this means you have the opposite of 4 times 4 times 4, and 4 times 4 times 4 is 64, so this is negative 64. Okay, let's look at another version of this, negative 4 cubed, and now the negative 4 is your base because the negative is in parentheses and the 3 is still the exponent. And so what this means is the negative 4 should be multiplied by itself 3 times. Okay, so negative times negative is positive, times a negative is negative. So you end up with negative, and then 4 times 4 times 4 is 64. So you end up with the same number in both of these examples, but for totally different reasons. Okay, so let's see when this is important. Let's now compare negative 2 to the 4th, where the negative is not part of the base, with negative 2 to the 4th, where the negative is part of the base. This means negative 2 times 2 times 2 times 2. 2 times itself 4 times is 16, and you've got the negative in the front. So it's the opposite of 2 to the 4th. Here, the negative is part of your base, so this means negative 2 times itself 4 times. So the negative is multiplied as well. And you may already know this, a negative times a negative is a positive. Those two negatives will give you a positive. And a positive times a positive is a positive. So this whole thing is positive. In general, anytime you have an even number of negatives that are multiplied, it's going to result in a positive number because each pair is going to give you a positive number. So in this case, it's going to be positive, and 2 times 2 times 2 times 2 is the 16. So in this case, these are not the same thing, and that's because they mean something different. Right? This is positive 16, this is negative 16. Let's try some more examples. If I write negative 1 to the 200 power and compare that to negative 1 in parentheses to the 200 power, then up here, this means the opposite of 1 to the 200, right? 1 to the 200, well, if you can imagine 200 ones being multiplied, no matter how many times you multiply ones, you're going to get a 1. So 1 to the 200 is 1, but you got the negative in the front, so it's negative 1 in this case. Down here, you multiply negative 1 times itself 200 times. There's an even number of negatives, so it's going to be a positive answer. And 1 times itself 200 times is positive 1, so you end up with positive 1. Okay, so 1 can be tricky when you raise it to a power. 0 to the third power means 0 times itself 3 times, which is 0, so that's how you deal with 0. If you have a fraction, like 1/2 to the third power, that means 1/2 times itself 3 times. And you multiply fractions by going straight across, so you multiply all the 1's together, and you end up with 1. You multiply all the 2's together, and you end up with 8. So that's how you deal with fractions to exponents.